Question 3, you're told z is equal to 6 plus 2i, and the usual I squared is equal to minus 1. Show that z minus iz is equal to this right hand side, 8 minus 4i. So let's simplify the left hand side. Z 6 plus 2i minus I times z 6 plus 2i is going to give 6 plus 2i, your knowledge of multiplying by I, minus 6i minus 2i squared. It's going to be a plus 2, that's your knowledge here. So you're going to have 6 plus 2i minus 6i plus 2, which is going to be 8 minus 4i, which is equal to the right hand side, QED. You don't have to say QED, it's just me being really annoying. Then you're asked to show the modulus of z squared plus the modulus of iz squared is equal to the modulus of z minus iz squared. Okay, let's do the left hand side first. The modulus of z, so your knowledge of modulus is the square root of 6 squared plus 2 squared. Shouldn't have to explain this now, but let's say 6 plus 2i is here. Out 6 and up 2. The modulus is the distance from the origin, as you all know. So that's going to be 36 plus 4, root 40. The modulus of iz is going to be the same. We've worked that out already, haven't we? Iz. Well, we'll do it again here. I times 6 plus 2i is iz. 6i plus 2i squared is the minus 2 now, so we're going to get 6i minus 2 plus 6i. We actually had a minus up above, so the modulus of this is still a 2 and a 6. I'm going to write it down here. The modulus of iz is equal to the modulus of z. Therefore, we're going to get root 40 squared, this is the left hand side, plus root 40 squared, which is 40 plus 40, which is 80. And that's my left hand side. So now let's look at my right hand side, this guy. We're looking at the modulus of z, 6 plus 2i. This is the right hand side. It's the modulus 6 plus 2i, and it's what we have up above, the z minus iz. It's what we got here, 8 minus 4i. So actually, spot that now, the right hand side is equal to part 1. The modulus of 8 minus 4i equals the square root of 8 squared plus 4 squared. 64 and 16 is 80. So we have the square root of 80 to be squared, which you can say is equal to 80, which is equal to the left hand side. Therefore, and you can rewrite this whole expression here from the beginning to show the examiner exactly what you've done. Part 3. The circle C passes through the points Z at the origin here and IZ as shown in the diagram, not the scale. Z and IZ are endpoints on the diameter of the circle. So the diameter of the circle, any angle standing on the diameter is a right angle. That's the knowledge here. We've worked out the modulus of these guys, root 40 and root 40. So to get the area of the circle, we need the radius. So we need this guy here, they're about radius. So it's just a right angle triangle, but root 40 on both sides. So you can see straight away, actually, connection to the previous part is going to be root 40 of root 40 to be squared. I'll put it in anyway to make sure, just to show you, which is equal to square root of, it's going to be equal to 80. Maybe I'll write out like this, the square root of 40 to be squared plus the square root of 40 to be squared is equal to x squared, the whole diameter to be squared. So 40 plus 40 is equal to x squared. So x looks like it's going to be the square root of 80. So x is equal to 4 root 5 in its simplest terms. So the radius is equal to x over 2. So the radius is going to be 2 root 5. So pi r squared for the area is going to be pi in terms of pi by 2 root 5 to be squared. So it's going to be pi times 2 root 5 to be squared. It's going to be 24 5s. So the area of the circle is 20 pi. So what they're looking for, the area of the circle in terms of pi, 20 pi, and that would be in units squared because we're dealing with area. Just seeing I left my square root out of there earlier. Careful. And last part of this question. The Moira, you knew this was coming up. Write this in polar form basically is what they're asking you. Let's have a look here. Where is this complex number? Positive, negative. It's in here. So just sketch it. Out root 3, down 1. Find the angle A. The tan of A is equal to 1 over root 3. Opposite over adjacent. You know this is 30 degrees. Which is going to be angle A. So theta is going to be 330. 30 degrees is pi over 6. You want to write it in radian. 30 degrees would be pi over 6. So 330 is 11 of them. 11 pi over 6. Just need or now. The modulus is equal to the square root of 1 squared plus root 3 squared, which you've seen these loads of times, is equal to 2. So in polar form, this is 2 by the cos of the angle, 11 pi over 6 plus I times the sine of 11 pi over 6.